Linear algebra is a very fundamental area in mathematics, but we will use it with wide range of applications. It's a very broad area. But with respect to machine learning, we'll use it to solve a specific types of problems. Right? Let me motivate you with a very simple example. So we saw, let's assume I have two features, right? This is a 2D data set, right? Let's assume I have feature 1 and feature 2. Let's take our iris data set, right? Let's assume this was petal width and let's assume this was petal length. Let's assume I have two types of flowers. One type of flowers marked here with a cross. The other type of flowers marked here with a circle, right? So let me call them circle flowers and cross flowers, right? Now, to separate these flowers or to be able to distinguish one flower from the other flower, one of the methods that we saw when we were doing exploratory data analysis was that we could draw a line like this, right? And we could say everything on one side of the line belongs to one class of flowers, everything on this side belongs to another side of other class of flowers, right? This we could do it in 2D. Imagine if I had to do the same thing in 3D, what would I do? Imagine if I have three features, right? Feature 1, let's say feature 2 and feature 3, right? And if my points were like this, right, in my three-dimensional space, right, I could again draw a plane like this. I could draw a plane like this and say everything on this side of the plane belongs to one class of flowers, everything on this side of the plane belongs to another class of points. Now in 1D we have a line to separate, in 2D we have a plane. What about 4D? What about 5D? What about 10D? What about any dimensional space? What happens? How do we understand the equivalent? So here you can think of a line as a linear surface that is separating one class of points from the other class. Same with a plane, right? It's also a linear surface which is separating one class of points from other class of points in a 3D space. Now, whatever we had learned in 1D, 2D, and 3D, how do we generalize it to higher dimensional spaces? Of course, we can't visualize the data in 4D, 5D, 10D, or ND. Linear algebra is the brilliant mathematical tool that we have at our disposal to help us take our learnings, our understanding, our intuition from 2D and 3D to higher dimensional spaces. We will see that your line, your plane, all these things are connected through beautiful and very simple and elegant mathematics. Linear algebra provides us those mathematical tools to help us operate in higher dimensional spaces. Because in machine learning, if I have 10 features, I'm operating in a 10-dimensional space, right? If I have 1,000 features, I'm operating in a 1,000-dimensional space. But of course, we can't visualize anything more than 4 or 5D, right? And hence, linear algebra provides us with the mathematical tools that we need to simplify and to generalize our learnings that we learn from 2D and 3D.